That's what I thought.
Time isn't a
Because
constant.
it's on the x-axis.
Yeah.
As well. Okay, so yeah, 9 was fine. I did that.
Okay.
It was good. Question 10. Yeah, this one I struggled with a little bit. I got there, I think, in the end, but I struggled it a little bit.
What was your thinking for part A?
So for part A, where A is positive. So what I did was I put it on my calculator.
Great.
And then I saw that the x equals 0 is always constant. They only go up and down.
Okay.
So that's what I got for the asymptote on the y, or like following the y. And then for the x, it was just x equals a because it moved up with it.
Great. So,
but the one that I got confused was with the coordinates in which it crosses the axes.
Let's see. So that's our asymptote, and that's our other asymptote. So one asymptote is x equals 0. The other asymptote is y equals a. The reason why it's gone up instead of down is because it's positive.
Okay.
Give the coordinates of any points where the graph crosses the axis.
So what I realized was when I replaced x with 1 and then x with 2, it went -1 then minus 0.5. So I thought it could be minus a over 2, but they wanted something else, like a different fraction.
You could graph y equals 1 over x plus 3, y equals 1 over x plus 4, y equals 1 over x plus 7. And you get it that way. The other way is basically it's when y is 0.
When y is 0.
So where it crosses the x-axis, the y coordinate will be 0. And then you could just solve for x.
So x equals 1 plus a.
X times 0 is 0, so you'd have to move the a over first.
So 1 over x equals a.
If you bring it to the other side.
Minus a.
Yeah.
That's a minus. So a equals -1 over x.
Okay.
And then you switch the x and the a.
Yep.
So you get x equals -1 over a.
Yeah.
So how did you think about doing that again?
Basically, where it crosses the x-axis, the y coordinate is 0.
Okay.
That's like as old as solving a quadratic. So you've got a quadratic, and it says find the roots, find the solutions. It's when it's equal to 0.
Okay. Yeah, of course. Okay, so that was that for 10. The other one, yeah, I just found the gradients and then the tangent one. Then I made them equal to each other and found different points. Question 11, I've circled. Oh yeah, this one, the mark scheme just confused me. So what I did was I made them equal to each other.
Yeah.
Then I got an equation. Then all of a sudden, it wanted me to use the discriminant, and I got lost. I didn't understand why.
X squared equals 9. What's it going to say?
So it was X squared minus kx plus k equals 0.
Hold on. X squared equals 9. Solve it.
Oh, solve it.
Yeah. Not a trick question. X squared equals 9.
Oh, 3.
And is there another very similar number that when you square it, you also get 9?
Minus 3.
Yeah. This one?
X squared equals 0. 0.
Equals 0. And what you'll notice is that plus 0 minus 0, same thing.
Mm-hmm.
Third one?
That is not possible. Let's use I.
Yeah. And so how many solutions were there for the first one?
2.
So that's got 2 solutions. Middle one?
1.
And last one?
0.
And so that's like 0 repeat real roots.
Yeah.
Mention that. That's one
So,
repeated root.
I understand that the discriminant shows how many roots it's going to have.
Yeah.
But I didn't see how or why they implemented it.
So b squared minus 4 ac all over 2a. So basically, if you if b squared minus 4ac is greater than 0, you get 2 real roots. If it's equal to 0, you get 1 repeated root, and if it's less than 0, you get no real roots. And
but why couldn't you just solve the equation and that'll give you two x values?
Okay,
when you could just use those. So the quadratic equation was x squared minus kx plus k equals 0.
Okay. So how many unknowns?
Too many.
Yep. You've got 2 unknowns.
Mm-hmm.
And so you can't do anything with that. So x squared minus kx plus k equals 0. So because of that unknown, you can't actually find the solutions for x or the value for k, but you can find a number of solutions that will exist. So b squared minus 4ac.
So what pushes us to find the discriminant is the lack of information.
Yeah. So in theory, it should be easier to find a number of answers as opposed to the particular answers. So to find the particular answers, what they actually are, you'd have to use the whole formula. To find just the number of solutions you'll get, you just find the discriminant. And if it's bigger than 0, then you got 2. You're going to get 2 solutions. If it's exactly 0, you'll get 1, and if it's a negative number less than 0, then you'll get none. Now with your calculator, you can just calculate them, so it's all the same. But for this particular one, you can't solve it because you don't know what k is. But what you can do is just find whether or not they'll intersect. So is a solution even possible?
Okay.
So if they want the number of solutions, just find the solutions. And if there's 1, there's 1. If there's 2, there's 2. If there's none, there's none. But if you had to show that there's no solutions, or if you had to, in this case, state the number of solutions where you can't solve it, then the discriminant tells you how many solutions you'll get.
Okay. So then from this, how do we find the value of k?
So let's see, some b squared minus 4 ac. Let's see, so that's k squared minus 4k.
What they did was they made it k squared minus 4k is greater than or equal to 0.
In this question, we're just doing what value of k graphs. Oh, determine for what values they intersect. Yeah. So they will intersect for two types of things: when this is equal to 0, or when this is more than 0. They won't intersect when it's less than 0. When it's less than 0.
So is that what it means by determine for what values?
Yeah.
So it means that.
And so you solve that.
So you can use a normal polynomials over there.
And B is inequality.
I don't know where my...
Yeah, so my one has inequality. Does your one have inequality solver?
I have a solver. I don't know if that's for...
So you could try that.
Could I not just try the polynomial and then determine the values afterwards?
Yeah, I just like the ease of this one. But
yeah.
Go on, try it.
-1 and 0. So it's 1 minus 1, 0. So if I get 1 and 0. Wait, hold on.
Don't believe so.
That's -4. So 4 and 0 is what I get.
Okay. And so what do you do next? You want when it's greater than or equal to 0?
So greater than 0. How do we determine it to be greater than 0?
You would have to sketch the graph. So basically, yeah, so sketch the graph.
Mm-hmm.
And then see where it's greater than 0.
So yeah, from these 2 points, right? 0 and 4.
But is it less than? Is it greater than?
Oh, where it's greater than 0. Oh, so x is greater than 4 and x is less than 0.
Yeah. So it looks like that. And so it's when x is greater than 4 and x is less than 0. And so those are your values.
So if we were to shade it on the graph,
so graph. So x squared minus 4x. And I did see some way to shade the graph as well for the inequality.
I think if you do type, it changes it to an inequality if you go to the right.
Ah, yeah, greater than or equal to. No, mine looks weird. I have to zoom out or something.
I think you can just click zoom and press the minus button, and it zooms out continuously.
Shift, zoom, and press the minus.
Yeah, now here you press the minus.
Do you not choose out or something?
No, just click the minus button, and it should...
Oh, well, I don't know.
I don't know. Or click exit because you've selected something.
Oh, okay.
And then redraw it, and then zoom and minus.
Ah, there we go.
And then plus, yeah, zoom.
Okay, so mine doesn't show the inequality bit. I don't know why.
So basically, we're finding the area which is when the graph is greater than 0, because those are the regions where there are 2 values of x, and that's what we want to find.
Yeah. And actually, I think I have it now, but yeah, it's not too bad. And then you draw that thing. Here we go. Oh, I don't know. It's just doing silly stuff. Yeah, but I think you get the idea. So it's discriminant because there's 2 solutions, and then discriminants because there's you're just trying to find the number of solutions because you can't figure out exactly what k is or x is. So usually the easiest just find the solutions, and if there's just 2, there's 2. If there's 1, there's 1. If there's none, there's none. We can't, so we have to use discriminant, and we know that the discriminant is either going to be equal to 0 or greater than 0, and so you just find when it's greater than or equal to 0. Sketch the graph and then just say it's when x is greater than 4 or less than 0.
Okay, good.
That's when y will be greater than 0.
So yeah, that's good. Now 12D, the last part. I think I got how to do it. It's just got a little bit confused.
So I'll just see if I can do it without the noise. Catherine now carries out experiments for the magnitude here on the box when it is moving. So let's see this box. Okay. And box is held at rest. So let's see. A box hangs from a balloon. The string is always vertical. The mass of the box hangs from a balloon. Okay. The mass of the box is 15. G. Okay. To find the magnitude of the air resistance on the box when it is moving. At the time when the box is accelerating downwards at 1.5, she finds the tension in the string is 140. Calculate the magnitude. Okay, how would you do that?
So we could take the air resistance acting upwards if it's accelerating downwards. So the air resistance going up. So it'd be 15G. That's going downwards. Oh, so it's 140 plus R, because those are acting upwards, minus 15G equals MA.
Okay. So you've got 15G minus R for air resistance, is it?
Yeah, that's
15G minus R. And was there anything else, sorry?
Wouldn't it be... Oh, you're doing it the opposite way, so then minus 140.
Oh, she finds the tension in the string is 140. Sorry, I didn't see that. Yeah, equals MA.
Yeah, so 15 times 1.5.
Okay. And then you solve it?
Yep. So I get minus 15.5.
Yeah.
So that's the air resistance.
And is it going? What's the direction of the motion of the box?
So we were looking in the downwards direction, right?
Mm-hmm.
And we thought that the air resistance was going to be acting upwards,
Right.
but in fact it's acting downwards, so the box is going upwards.
I think that actually, if we say it's accelerating down,
Yeah,
I mean, is it not going down?
but if the air resistance is the opposite, then the box must be going up, right?
So if we said that A, hang on, so we might have muddled this up a little bit.
Could we try doing it like the other way? By saying that tension is positive and our air resistance is acting upwards?
Well, we said that, so 15G, that's positive, yeah?
Yeah.
We said that the resistance is negative, and we just assumed that that was going up. So we took, and we said it's accelerating downwards at 1.5. So we've taken downwards to be positive and upwards to be negative. So I think that's going to be upwards. You can switch it around if you like. Should get the same thing.
But since the air resistance is negative, then that means that it's going against the value or the direction that we originally thought it was, right?
Oh yeah, I see what you're saying. So it's minus that. So it's like minus R.
So
15G.
It's acting downwards on it. So if it's acting downwards, then the box must be going upwards because it acts against the motion.
Yeah, so I think it's actually going downwards. Because it's minus. Yeah, it's downwards.
So the R is going downwards.
Yeah, so if we had gotten like 15,
yeah,
then that would show that that it's going up. But we got negative, and so that means it must be going. That's like 15G plus 15.5, so it's going the same direction. So I think it's downwards, all right. R is downwards, so motion of the box is upwards. Yeah. Wait. So what were we actually trying to? Oh, so R is downwards.
Yeah.
So box is
and
upwards.
then the box is up. But then how is the box? Oh, so the box is slowing down.
Yeah.
Ah. Okay.
Yeah. And so if the resistance is down, then it must be going the opposite direction.
Yeah. Yeah. That makes sense.
Any other questions with that one?
Not with that one. No.
Okay.
I'm just looking.
What's it?
How's that?
You would sub in X and show that the answer you get is Y. In this case, for a circle. Oh, sorry. Show that the point lies outside the circle. Lies outside the circle. You could find the length from the center to 1, 2.
Length to the center.
Yeah. So if you found the length of the line from 2 minus 3 to 1, 2, and if that's longer than 5, then it's outside the circle.
Longer than 5, because that's the radius. So you can't substitute in those values into the equation.
That's what they did. That's what they did, and they got 26. That's one way to do it. So they subbed in 1 and 2. Is that what they did? Yeah, they subbed in 1 and 2. So you just sub them in. That's an easier way.
Oh, okay. And what was the method that you were saying before?
26, which is equal to 25 plus 1, so outside. I was thinking you would use Pythagoras. It's probably more work though. So this here, if you did Pythagoras for these, I think you would get root 26.
Uh-huh.
And that's bigger than root 25.
So you're essentially looking at the distance and seeing if the distance to the center is greater than the radius.
Yeah, and so, yeah, if it's, yeah, exactly. And if it was less, it would be inside the circle. If it was exactly, it'd be exactly on the circle.
Mm-hmm. Okay.
Yeah, so let's take a look. So, yes, this one, if you have to find, once you have it in completed square form, so they made you put it in completed square form. So there's lots of ways to find the minimum. You can use differentiation and stuff. They wanted you to, once you have it in completed square form, then you can just say, it's going to be the opposite sign of x and the same sign as y. Mm-hmm. And that's because the smallest square number is 0. And when x is 0, y is 3.
Yeah.
That's where that comes from. This one, just the Pythagoras for for AC must be equal to the Pythagoras for BC. I mean, just solve it.
Okay.
That was straightforward. So this one, they simplified greatly. They just said, it went an extra 525 meters. And so he would have to go an extra 525 meters. His speed is 25 meters per second. And so time is 525 over 25, distance over speed. Yeah. So it's an extra 21 seconds. So they simplified that. So this one, if you ever have to find the equation of a tangent, find the gradient of the radius to that point, and then its perpendicular gradient.
Yeah.
And then just use the point P, not the center, because it doesn't go through that. Yes. Any questions with that one?
No, that one answered. Yeah.
So this one, like T is X. Yeah. Time is always the independent variable. Explanatory and all that. This one, that's okay. If you have to find the coordinates where it crosses the axis. So like you said a minute ago, when it crosses the y-axis, x is 0. For this one, where it crosses the x-axis, y is 0. And that's just because, like doing quadratics, make y equal 0 and find the x.
Okay.
So usually, why don't you just find the two solutions or the one solution or whatever? It's because we can't. Usually that would be the best method. And so although we can't find the solutions, we can say for what values of k we would have solutions. So you just get the discriminant, b squared minus 4ac. It will have one solution when it's equal to 0. It'll have two solutions when it's greater than 0. And say, they'll intersect for, greater than or equal to. Sketch the graph and then just use that.
Okay. And usually if you had values and did the discriminant, it would give you a value, and that you could use to see how many roots there are.
Yeah, so if it gave you a value of 5 or something, then it's like 2 real roots. If it gave you a value of exactly 0, 1 repeated root. Or minus 3, then no real roots. Because you won't have square root or negative.
Yeah, and then you check by looking at the points either side to see if they're positive or negative, to see if it's a minimum or maximum as well.
Yeah, that'll help. Let's see, so this one, it's f equals ma, sub it in, and that was a bit tricky. The backwards thing, r is downwards, so the box was upwards, minus, but it's just f equals ma. Put it in the solver. This one, just sub in the values, and it's bigger than 25, and so it's bigger than the radius, so it's outside.
Yeah.
How was that, Gregoire?
It was good, thank you. Just checking, the next session is on Saturday, correct?
just check my thing.